So now we have a half hour for discussion of both of the recent talks. Please don't forget to introduce yourself before your question or comment.
Judy Kegel from University of Southern Maine. Can we see the sign language example?
You can. Thank you for that question. Yes, you can see it immediately, in fact. I have it queued up somewhere here. Incidentally, the timescales are the same for dynamic vision, just in case you want to know. So here is an experiment that former student So-An Huang, part of her dissertation years ago, I think. So she did, she filmed signers and then did the same chopping up and reversing experiment and asked for intelligibility as, in this case, proportion correct. In this case, there also is another manipulation, namely compression and expansion, which is this yellow line. But and she did this way out. Obviously, the overall scale is much smaller. So the interesting thing she found in her thesis is that if you go out to about 100 to 200 milliseconds, your performance is still fine, and then it falls sharply off by 300 to 400, and then it flattens out. Right? So there's a much longer scale over which you seem to want to individuate, let's say, perceptual objects for further interpretation. So this is all in So-An's dissertation, and presumably eventually not yet rejected.
I don't know if I'm going to remember that, but I'll try.
A question for Mark. Daniel Harbour, Queen Mary, University of London. I wonder whether snaps are another kind of basic sound that we should maybe take into account for two reasons. One, if you just think of them in the physical world, they are very salient. If you've ever been out late at night in a forest and you hear a twig snap, it really... Yeah, no, more like, or equally, if you're trying to stalk something and you snap a twig, you've basically blown it. And they are sounds that are prominent in quite a lot of languages. So you get, non-pulmonic egresses, you get pulmonic ingresses, and you also get disglottalization. So that's thing number one. But related to it is that if you then think about onomatopoeia in these terms, so in English, ping versus bong, it's sort of interesting that the small sound has got this kind of unvoiced sound and b for the longer one. That extends into these kind of snap-like sounds as well. So in Georgian, you get these really interesting triplets where the voiced onset, so something like brdg for the big sound, the aspirates prtk for the sort of immediate sounds, and then the glottalized one brtk for the really kind of twinkly little tinsely sounds. So one, would you include snaps? And two, have you thought about onomatopoeia in this context?
Yeah, on the first, somehow that never occurred to me. At first glance, I would just consider that a hit, but it's not. It has aspects of hits. And does it end up looking like a hit in terms of its spectrum over time, or does it have some unique structure? Because it ain't a hit. Now that I'm thinking through it, it is different. So I have to think through what even that is and how common that might be. So the actual breaking itself of a solid, some kind of, might itself be another kind of category, which one could, maybe it's I think it's almost a separate category. It's not even a subcategory of hit. How general that is, I'm not sure, but yeah, I think that through. On the onomatopoeia side, certainly this opens up whole new domains for thinking about the kinds of meanings that people have, because now you can say, okay, this is what it means. This kind of fundamental structure is found in these ecological ways, and so anytime you find b and g, it sounds bouncy and blingy, like an elastic thing, whereas the unvoiced ones are the kinds of are more likely to have a complicated hit when they're hitting. And in fact, I had a student that was trying to look at grapheme correlates to this. So if you look across many writing systems and you ask whether or not the voiced plosives are more likely to be smoothish, I can't remember yet, and the other ones are more likely craggly in some way, with some kind of visual complexity, he found a weak but statistically significant correlation across these, so that there was this very weak tendency to have the boingy ones, the boingy sounding ones look more boingy. And so this gets back to this, the standard story for this kind of, and it's usually something like Baba versus Kiki or whatever. And the story here, rather than something having to do with your mouth, is that literally, were you to drop this and it were to hit the ground,
think Stan was next. And
This is also a question to Mark. I really like the story, of course, and it's very close to this idea of recycling that I've developing. But I had a specific question about the music story and the idea that the Doppler effect might play a role here. So the sound moves at 300 meters per second, right? And humans move maybe at 1 or 2 meters per second. So is there really enough room for there to be a Doppler effect and for us to be sensitive to it?
Yeah. Well, I think they're trying to record it. Now it's on now. So even at 1 meter per second, you're getting about a tenth or eighth of a semitone on the piano, which is still. It's now it's back now. Yeah, so